Hello, we're going to talk about sustainability in semiconductor manufacturing and how digital transformation helps with that. I have with me Manish Sharma, Global Industry Marketing Leader, Emerson Machine Automation Solutions. I'm Mark T. Hoske, Control Engineering Editor and Content Manager since 1994. Manish, welcome and thanks for today's discussion. Manish leads the industry marketing segment for semiconductor, energy, and water industry and has been with Emerson since 2011. He has 20 years of experience in marketing, product management, and control systems R&D and holds 3 U.S. patents for control system solutions. By way of introduction, please share some things in your background that help with what you're doing now.
Thanks, Mark, for the introduction. Pleasure to be here and talk about semiconductor industry and the sustainability as it applies to the industry. Regarding me, I have been fortunate to work for the top organizations like Emerson, General Electric, and Honeywell, where I have worn different hats, different roles, different hats, and starting from the software engineering all the way to product architecture, product management, and now the global industry leader. So these experiences have allowed me to build up my career from the point of view of the customer. We have always worked in the product development industry, so customer was the focal point of whatever we did. So the mindset has been, what are the problems that we are solving for the customer? And that has continued from the starting of my career to till date. So product selling or product positioning is one aspect of whatever we do in our day-to-day life. But if we mix with the solution selling or consultative selling approach, or what are the pain points of the customer, that's what I would like to continue doing. And that's how I approach my job.
Very good. What do you consider digital transformation and how can that help with semiconductor manufacturing?
So digital transformation is a buzzword nowadays. It's a big topic, and it's a continuation of the evolution of the industrial revolution, the way I put it. The industry has evolved, more and more mechanization happened, then more and more electrification happened, and now we are at a stage where we are harnessing the power of confluence of data, higher control system, higher level control system, the better instrumentation that we can put on the field and bring it all together. You have so much of data that you can use to derive insights, draw patterns, affect the change in the control system. So that's, in a nutshell, the digital transformation. Now, it means different things to different people. And you have to look from a context of what a particular customer wants to do. An automobile manufacturer or a semiconductor industry will have different KPIs that they want to achieve from that. So it's usually a top-down approach where you want to achieve different results in your industry. You have different business drivers, but eventually it is a top-down thing. The executives decide what they want to do in their particular industry or a factory, and the plant manager have their own, what they want to achieve, and the shop floor people may have their own concerns, whether it's going to job reduction or it's going to make their job easier. So every party has to be on board. There has to be a unified plan. Now, talking about semiconductor industry, if we take a look at what are their top pressing points, they consume power, water, gas, and host of other things in large quantities. And those are their top operational costs. So naturally, one of the things that they want to achieve is to drive down their operational expenses. Any software or semiconductor foundry is basically a huge capex. So billions of dollars are pumped into this business, and they are fighting for wafer thin margins because there is always a competition in, at least in the broad-based segment. There are a few niches when it comes to processor manufacturing, etc. But the fact that somebody is a leader in that field means they have already achieved process efficiencies and manufacturing excellence. So semiconductor industry, digital transformation, it's again an evolution. And I'm going to talk about the different phases of the steps that people need to take to start the transformation journey. But it begins with identifying top KPIs, what you want to achieve, how you want to achieve, what are the elements of achieving that, be it different machineries, be it a different control system, the continuous monitoring process. um, are we hitting the goals? Do we need to get better and better at it? How do we get better at, let's say, waste reduction, or the reducing the mean time between the equipment failure or a machinery failure? Huge capex industry has to be running. Otherwise, it's $1 billion paperweight. So you need to be very sure that it's running all the time. I'm going to share a graphic here, which will show the journey of the digital transformation in any industry, and then we'll talk about how it matters. So from a control system point of view, most of the industries, and I'm generalizing it deliberately. I'm not specifically talking about semiconductor industry, but it applies very well to semiconductor industry. It starts with monitoring. Most of the end customers think that they are monitoring enough, but once they define the KPIs, what they want to achieve, they might realize that the elements that they are monitoring or the parameters they are monitoring just are not instrumented enough. So you may have to go back to putting more instruments, getting more data. Then once you are at a mature level of monitoring, you go to the diagnosis phase when you start collecting data and storing data in a historian. What do? Let's say you have 500 machines at your plant and you want to monitor the vibration level of the same make, and then you want to monitor the vibration level, and you are able to basically pinpoint what are the top 10 concerning equipments in your plant. So you can focus better on them. You move to the diagnosis phase. Now you want to basically fix this problem. And you may realize that, okay, I don't have enough data. I may need to go back to the monitoring phase and then again continue with the diagnosis. Once you have reached a stage where you are mature in monitoring and diagnosis, you may go to the prediction phase. Okay, I can predict that this particular equipment is at the end of life. It's going to go bad. For example, an RO plant, reverse osmosis plant that's in the semiconductor industry, may have the candles getting choked. And there are a few hundred candles or 1,000 candles. So you can have a trend which shows, okay, candle number XYZ is getting clogged. It may need a replacement. So you don't have to have a schedule-based maintenance. You're going out with a paper pad and then going and monitoring everything. You just go exactly where the problem is. Uh, replace the candle and be done with it instead of wasting all the time and money doing that. So prediction comes into play in what we call condition-based maintenance, which is a huge cost saver for semiconductor industry or any industry. Then you further optimize the process. If I were to change a particular element of the process, will my process have a better result? That's when you start optimization, and eventually this wheel may continue. You may have to go back few steps and then put more instrumentation, put more control strategies. And then eventually you are at a stage where the process is learning as to what it's doing. And there is a lot of machine learning algorithm which starts coming at the predict phase itself. So statistical analysis of the data is necessary to start doing the prediction, doing the optimization, and the learning of the process. So this was basically, in a nutshell, about the different stages that you go through once you define your KPIs.
When we talk about sustainability in semiconductor plants, what all does that include, and how does the semiconductor industry doing things compared to other industries?
So as I said, semiconductor industry is a huge power guzzler and a water guzzler. I mean, if you look at 1 square inch of a microchip requires 46 liters of ultra pure water. And that's ultra pure water, not talking about the water it takes to make 46-liter ultra pure water. And it takes close to 7.5 kilowatt hour of power for a single 1 square chip. So in addition to the power and water, you have all the corrosive gases. There are n number of gases that are used for different purposes of etching and planarization process, etc. So for semiconductor industry to be talking about sustainability, it's actually a compulsion. a severe drought in a particular area can actually jeopardize the factory production. You have $50 billion pumped into a location where there is no water. That's not going to happen. And even if you have enough water, to stay competitive from your next competitor, you have to have refined processes which does not stress the resources. So that's where basically semiconductor industry has to, it's a compulsion to take sustainability initiative. Not only is it about the operational continuity, because not having sustainability in your roadmap is going to, you know, take your operational cost the uh, out of the band where you can be profitable. But as technology gets more and more sophisticated, we are going into the nano, it kind of more and more. TSMC is competing with Samsung, and then there are machines which only one or two of the OEMs in the world make for photolithography. So there is a race to go into a different, in a lower form factor. And as you do that, more power is needed, more water is needed, a better control of the deployment of these resources is needed. So yes, digital transformation is something which semiconductor industry is looking at, and they are actively embracing it. And I'm not going to say that they are at an end stage of it. It's an evolution. It's a journey. There are different stages of adoption or interest in the field.
How are semiconductor fabrication plants tracking and reducing energy consumption? And if there are differences to other industries, what would they be?
So regarding differences to other industries, there are other industries which are power, water, gases, guzzlers, like automotive industry, or agriculture is a huge consumer. I think it's the largest consumer of the fresh water that is generated or pumped out from the ground. But those industries are a different conversation altogether. In semiconductor industry, the market leaders at least are very serious about it. The interest is very serious. They are beginning to tinker with the energy management, water recycling, etc. But there is a broad trend of, although the industry is competitive, but there is a broad trend of, let's say, oligopolistic market pockets inside that. For example, there is a market segment called memory chips, and there are few players who are market leaders in that, and they may not feel the compulsion to drive down the operational cost because they are killing it in that market. uh, Processors, so contract manufacturers make the processors. Some of the OEMs like Intel make their own. So overall cost reduction is always a compulsion, but it's not like I need to reduce it from tomorrow, otherwise somebody else is going to take away my business. That doesn't happen. So that's one thing. The compulsion for few players may or may not be there, but again, they have their own internal mechanics to drive the cost down. So yes, uh, as I said, it's a huge capex industry. So the end users don't really want to do too much disruptive in their processes. The approval of one scheme of things or a control or a product line takes a lot of time. The machines themselves are multi-million-dollar machines there, so you don't want to tinker around with the proprietary processes that they run, because once deployed, uh, if they break down because the changes were there, it's going to be a huge problem for the machine OEMs. There are contractual obligations, the output will be stalled, and it's going to be a big problem for both the end users and OEMs. So there is always a cautious approach to adopt new technologies, but they do rigorous amount of testing. But definitely there is something that steps are being taken.
What are some of the strategies for increasing manufacturing uptime and availability, and how does that relate to plant-wide overall equipment efficiency, OEE?
So there are multiple strategies that can be adopted to increase the plant-wide OEE. First of all, identification where the fault usually happens, and that comes back to the wheel that I was talking about. The big wheel of monitor, diagnose, and that's the majority of the control system and the machines that you end up using. Now, how about not really putting in the redundancies in place and having a tighter process, but a more reliable process? So that's more cost effective instead of having redundancies at machine level, which will not work. You can have, but you cannot have too much of it. Uh, Instead of that, you have a more reliable control system which diagnoses the fault better, which helps you predict when the fault is going to happen, so you can actually tweak around the process, get a work order filled for an OEM, for example, or be proactive in solving the problem. So from a control system point of view, this translates into this. You should have a truly highly available control system. Like we have, Emerson has pack systems. Uh, while the competitors may have their redundancy broken during a hardware upgrade or a software upgrade, we support the different firmware versions or the hardware versions. Then capabilities. Now, edge is a different topic altogether. Let's dwell in it a bit. Uh, there is a PLC, a programmable logic controller, which runs which runs on a real-time operating system, and your strategies are run. It is hypervised, and on the other side of the PLC, there is Linux operating system, for example. Uh, some some OEMs have Windows, but let's not talk about it. There are multiple challenges to Windows, and I don't even consider that too much of an edge control system. So you have the strategies running on the real-time operating system. The data can be transported to the Linux side. You can have machine learning algorithms running there and affecting change in the process. So those are the edge capabilities. Let me project a quick example to share my thoughts on the edge capabilities. So this is a very basic example of what an edge computing means. You observe, for example, point number one, you observe what's happening in the field. It goes to the PLC. The PLC shares it with the edge control. We call it the pack edge on the Linux side, the operating system which is running there. You can have multiple strategies running there, which can pull the data from the external cloud because there is a historical data you need to run statistical analysis on, or you can run the algorithm even on the cloud, and the change will eventually come on the pack edge side. Now, from the package, you push your command back to the PLC side and you affect a change in the process. For example, here you are monitoring the current flow rate. You do a machine learning algorithm on that and you realize my flow rate should be X plus delta to have a better output. And that is the delta is given by the edge controller. The strategy is running on that. And then it goes into changing a val position to affect that delta change. Now, you don't want to do this on the PLC side. You cannot. I mean, the PLC is sequentially doing what it is supposed to do. The logic is being done. You need a parallel processing, but at the same time, it should be near to the process so that the changes are at a millisecond level or even a second level. You send it out on the SCADA, and then there is another machine doing it, and the command comes back. By that time, the picture has changed. So the closer to the edge you are computing the changes, the better your process is. Cybersecurity is another aspect. So we talked about the true high availability. We talked about the edge computing. Now let's talk about cybersecurity. So again, PAC systems have Ashley's level 2 certification, and we have encrypted communication between clients and the PLC. But there are different attacks that happen, and end users and the OEM should be very mindful of the fact that every semiconductor industry factory is actually a critical infrastructure. You can have a denial of service attacks where the hackers try to hose down your control system. It's a control system usually that's affected by meaningless commands. Or somebody may try to impersonate some other client by sitting in the middle of a client and a PLC. And then the PLC starts accepting the commands from this fake client. That's called the man in the middle attack. Now, the idea is to have an encrypted communication between the two objects, PLC or a client, so that that handshake is not broken. And PAC system has that inbuilt by design. Energy management is another angle, is another element. We have Pro Energy Solution. Basically, the idea is 45 to 50% of the energy is consumed by the machines that um, either make the chips or do different processes. You need to control that. You need to monitor that, how much energy is being consumed by those machines. Then the rest of the 50% is consumed by utility process like water, production, gases, uh, power consumption of for different other utilities, fire prevention system, sprinkler system, etc. So, uh, and the clean room, one of the most important one, HVAC. So that's something energy management sits right at the heart of having a good sustainability initiative. You cannot have sustainability being driven in a semiconductor factory without knowing where your power is being consumed. And energy management is right at the heart of it. Now, different elements. There are multiple OEMs providing water, gases, sprinkler system, monitoring, building management, machines. There's so many moving parts. You need an integrated visibility into the whole process. You can have individual operator stations or SCADAs for different processes, but somewhere at one level you need an integrated system. Now you can imagine there are different vendors, different machinery supporting different protocol. You need a platform like a Movicon Next, which supports different drivers or have the capability to absorb or host different drivers to connect to disparate systems. So those are basically the strategies that can be adopted as a part of digital transformation. And we'll talk more about it probably in the coming questions.
What types of customers would be most interested in these kinds of offerings?
So let's segment what are the different kind of customers from our perspective. And or let's say who are the different elements or different actors in the scheme of things. One is the end user. So end user, we'll talk about end user at the last. Another one is machine OEMs who provide machines. So they can benefit from, let's say, going to a monitor or a diagnose stage right now, more instrumentation, more insights about what their machine is consuming, what is the output, what are the vibration levels, what are they consuming in terms of raw materials. And you can have, say, 10 machines in a plant of the same kind. You can have benchmarking going on as to which machine is doing a better job. It's like students in a class, not everybody scores an A plus. So you try everybody to get from a B to A plus. So that benchmarking is very important. That diagnosis is very important to predict what is needed to come to a stage called, in manufacturing, we call it a golden batch. So when most of your output is on a peak, a very sharp peak, and everything is cluttered to where you want it to be. So those kind of things can be done using an industrial PC, which can host a package, and you will have multiple strategies running, which can run statistical analysis or machine learning algorithms in conjunction with your other proprietary processes. So I believe machine OEMs can benefit. Then there are third-party OEMs, which we call it balance of plant. So balance of plant means the core manufacturing and the balance which supports that manufacturing. So power, water, gases. Those are just the three examples I'm taking. For example, water. You may have top OEMs for water, like Veolia. Now Suez is a part of Veolia, Evoqua, or anybody who may have a contract to supply X gallons of ultra pure water per day. Now, that could be one of the business model, or an end user may be managing their own water plant, but eventually they need the water OEMs to get the plant up and running. And so uh, there is a lot of significant amount of power that is consumed and water that is consumed. So there is an element of monitoring the energy consumption, uh, making it high available, be it unhackable, all the elements that I talked about earlier. and scalable. You may have a migration that is upcoming, the factory is expanding, but if your control system is not scalable, then you are done. Either you have to rip off the old one or you have to set up a new plant, and then you have to manage two plants. So the control system should be scalable also. So system integrators, they are what provide basically the panels or the solutions to the OEMs. Talking about control system, they are the panel manufacturers, or they provide a total solution to the OEMs. So they can definitely, again, they may have a requirement to ship 50 panels, but they want to monitor them remotely. Edge technology comes into play. Web HMI comes into play. They should be able to remotely monitor. Uh, let's say in US, you have in Texas, you have in uh, Pennsylvania, you can have plants spread across, and then the same OEM is providing elsewhere, everywhere. So you need a central monitoring. That's something which an edge solution can provide. End user, uh, it's a big topic, but yes, what we really want, what end user can really benefit from is again the high availability, the cybersecurity, because ultimately it's their plant. But when you look at the digital transformation and the end user decides, I'm going to transform my plant, I'm going to have, these KPIs, reduce wastage by X%, have more output in the factory, etc., etc. Uh, but at some point of time, their engineers are going to play with the system and they are going to program new strategies. They're going to have more displays. So you need a system which is easy to work with. You don't need 5 or 7 different, configuration tools. We call it the tool chain. Uh, you should have one single one. We provide that. Each and every product can be configured using our machine edition. So that's one of the things. Easy to use, be cyber secure, highly available, have energy management capabilities, and must be very reputed and robust.
Very good. What are some other key benefits to these products and services? You mentioned many along the way.
So I have already talked about, I don't want to do a comparative analysis of the different products, but our high availability is truly highly available. For example, let's go deeper into it. We synchronize on every sweep cycle instead of just synchronization by exception. We have an industry gold standard in terms of cybersecurity. We are the only Ashley's 2 certified controllers. We have a full encryption communication going on between different clients. We have in our, offering not only the SCADA, but different other proprietary packages like Pro Energy or ProLean. So Pro Energy is an energy management solution. ProLean is a plant operation solution, which increases the operational efficiency, the OEE of the plant, overall equipment effectiveness. So multiple product lines all have their differentiators compared to other competitors. So plus ability to scale back. For example, even our latest PLC model supports is backwardly compatible with the old family of IOs. So in most of the places where the migration is done, they want to keep their old IOs. They rip out the PLC, they put the new PLC, and everything is working fine instead of rewiring and taking out the IOs and all that. So our migration is very fast because of that, and we have multiple success stories when it comes to that kind of migration. And we continue to support that in the future as well.
Do you have other recommendations or things you'd like to discuss as we finish up? And please let people know where they can learn more.
Yep, sure. So, it's a journey. Digital transformation is a journey. And start with setting up infrastructure in place first. Once you have the KPIs in place, look at what are the gaps in infrastructure, because applications will be developed upon what are the business KPIs that you set up, which means what are the insights that you want, what are the processes to focus on, what data do you need, what do you do with that data, what are the applications that need to be developed, And once you achieve your midterm goals, do you want to go back and instrument further? Uh, that's one. Then choose your platform very wisely, because it's a journey, incremental journey. You need to add elements, you need to remove elements. First of all, it should be high quality. It should be forward and backward compatible, because you don't want to be hit with, okay, um, I have reached midway journey, but I don't know how to proceed further. That's something which shouldn't happen. You need to be able to, you know, fill more gas in the tank and continue with your journey. So that's it. It's not a one-time deal. It should be easy to configure. As I said, your engineers would be working on it at some point of time. Uh, they should they should buy into the whole thing. Executives start, the CTO starts the, I want to do the digital transformation. I need to do the digital transformation because, the finance is saying I need to cut down the operating cost by so and so. Goes to the plant manager, he even says, awesome. I need predictive capabilities. I need to predict where my machines are going to go down because it goes down at 12 o'clock in the night. I don't like it. So I should be able to know when does it do that. Operators, they are roaming around in the field, calling up the central control room. Can you give me a data on this equipment? No, that should not be the case. They should have a web HMI. But everybody should buy into the whole thing. And that can only happen if it's convenient and meaningful and quantifiable to everybody. So from an operator point of view, it should be easy to work, single tool chain that I talked about, machine edition. All equipments are integrated and should be able to have a clear view of what's going on. It should be truly highly available. It should not break down if you are trying to do a patch. There is a cybersecurity patch that has come. You're trying to basically put it in the control system and the redundancy is broken. That's absolutely not a good deal. Let me and yes, the last point, focus on cybersecurity because that's going to hit one of these days, basically everybody. It's a matter of time. So your control system, control strategy, overall strategy, I wouldn't say it's not just the control system, it's an OT strategy also and IT strategy because ERP systems or production systems can be hacked. So those are the ones that should be taken care of. I'll show a integrated picture which kind of gives a clear view of what I'm talking about. So here is a typical scheme of, or let's say an architecture. It covers the clean room, which is extremely critical for a semiconductor foundry. Because if your clean room goes down, uh, you can have contaminants and the work in progress inventory will go bad most of the cases. So ultra pure water control. Ultra pure water, again, dwelling into process is in different stages. You have reverse osmosis, demineralization, and then nanofiltration, etc. So, and then there are fire system, gas management system. This is how it all comes together. You have edge controllers integrating all the processes together, going into a single SCADA. The historian is historizing the data. The data goes to the cloud for different processing. Um, and you can derive the insights from that data, and you can have an edge computing which intervenes directly with individual processes. So every edge controller uh, that's guiding the whole process of a particular segment will independently work with either a chiller or a cooling tower or an AHU. Then ultra pure water control will do the same for the other processes in the water segment. So this is basically a bird's eye view. It's much more complex than this because then there are different elements of, the different models of IOs, different other processes. This is just very simple, but it kind of gives a view about what is supported. Regarding the other resources, either contact me. My email will be at the end of the article, or you can go to the emerson.com website. We have multiple businesses working in semiconductor industry, and we have a solution and insights and something to offer to the semiconductor industry, which is much more than what I talked about today. I talked from a control system perspective, there are other businesses which provide different solutions for different elements in the industry.
Well, thank you, Manish Sharma, Global Industry Marketing Leader, Emerson Machine Automation Solutions, for the discussion, the perspective, and the insights. I'm Mark T. Hoske, Control Engineering Content Manager. Thanks for joining us.
Thank you, Mark. Pleasure is all mine. Thanks.